Hello and welcome to the SSE's Symposium, Anomalies in Modern Astronomy Research. I have with me Professor Avi Loeb. He is the Frank B. Baird Jr. Professor of Science at Harvard University and a best-selling author. He has written 8 books, including most recently Extraterrestrial, and nearly 1,000 papers on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. Loeb is a director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics, and also serves as the head of the Galileo Project. Welcome, Avi.
Thank you for having me. It's a great pleasure. As mentioned, the anomalies are really fundamental to us discovering new knowledge about the universe. And the challenge is, of course, that you don't want to pay attention to a low signal to noise ratio, because then you will spend your life on irrelevant noise fluctuations. And however, if there are intriguing signals, we better get more data. So that is the general message I would like to convey. And most importantly, in the mainstream of academia, people are blocking basically shoving under the rug any deviation from what is considered popular, and that suppresses innovation, suppresses the advance of our knowledge. Because, as I said at the top of this first slide, when you're not ready to find exceptional things, you will never discover them. And that was the basis for my book, Extraterrestrial, that you can see in the middle, that came out 1.5 years ago. I just submitted a sequel, a second book that will appear in June 2023. And I'll discuss in a few minutes the content of this book. I also wrote last year a textbook of more than 1,000 pages on the search for life in the cosmos, that you can see, the cover of which you can see on the right side. And then what you see on the left is an exhibit by the German photographer Herlinda Quilbel. In fact, it's showing right now at MIT. I visited that exhibit last week, and also in Japan right now. It started in Germany. And she came to my office a few years ago and asked me to write on the palm of my hand the question that I regard as most fundamental for us, for humanity. And I wrote, "Are we alone?" Now, it looks like this question is of great interest to the public, anyone interested in spirituality. And the evidence for that is that I got an email last week, this is really recent, from a rabbi, and she said that she gave a sermon on the high holiday of Yom Kippur, the Jewish holiday, expecting the unexpected. You can see it on the right-hand side, where she was inspired by my book, Extraterrestrial. And I wrote an essay about it on Medium. I write every few days a commentary there, and you can see the essay on the left. I highly recommend, if you're interested, in the connection between spirituality and the frontiers of science. Now, the Galileo Project includes 100 members by now. This is a photograph from a conference that we held at the beginning of August, just a couple of months ago. The first conference, the project is 1 year old, and we celebrated the first year accomplishments. I'll describe in a few minutes what we are aiming to do. So let me start from astronomy, because after all, that's what brought me to this subject. What did the scientific method teach us about the universe? Well, the biggest message I take from the past 3 decades that I practiced astrophysics is that we should be modest. Because somewhere between 3% and 100% of the sun-like stars host an Earth-sized planet in their habitable zone. We know that from the Kepler satellite data. So what we find in our backyard is not unique or privileged. There are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. So we need to practice a sense of cosmic modesty. It's not about us. The universe is not about us. And when you see an emperor or a king or today you see Putin trying to conquer a small piece of land. Usually it's an alpha male. That is not very impressive because it's just like an ant trying to hug a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from. I have 2 daughters, and when they were very young, they thought the world centers on them. And that changed when we took them to the kindergarten. They had a psychological shock when they realized that there is a smarter kid on their block. So our civilization will mature by finding others. And my point is that Albert Einstein was not necessarily the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. This is a cartoon that was drawn when Einstein died, and it shows the Earth with a plaque, "Albert Einstein lived here," as if humanity is most proud of that. But there must have been smarter scientists who lived on an exoplanet around another star 1 billion years ago. I'm pretty confident of that. And the civilization who benefited from their wisdom had enough time to use chemical propulsion and bring probes all across the Milky Way galaxy, including the solar system. Because most stars formed billions of years before the sun. In fact, they formed the peak in the star formation history is 10 billion years ago. The sun is only 4.6 billion years old. So it's a relatively late bloomer in cosmic history. And it's quite possible that there are probes with artificial intelligence that are filling the Milky Way galaxy. And this is not a philosophical question that we should debate about. Many people make the mistake of debating and debating, talking and talking. It's not a matter of talking about it. We can just look up and search. That's the way science is done. And that was pioneered by Galileo Galilei, who said, look through my telescope and you might figure out that the Earth moves around the sun. But the theologian and philosophers of the day said, no, we don't want to look through a telescope. In fact, we will put you in house arrest. Today, they would have canceled him on social media. So what do we know about objects from outside the solar system? Turns out that only over the past decade, we discovered the first among them. So the first report was in 2017 by Pan-STARRS in Hawaii, and it monitored near-Earth objects because that was the task that Congress gave NASA when this telescope was constructed. Look for near-Earth objects. We are afraid of those. They can hit the Earth. So one of these turned out to be moving very fast, and it was obvious that it came from outside the solar system. So that was the first one reported. It was not named the Oumuamua, which means a scout in the Hawaiian language. But in fact, the first interstellar object was identified 4 years earlier. It was a meteor, 0.5 meter in size, instead of 100 to 200 meters, the size of Oumuamua, roughly the size of a football field. So this one was much smaller, but it was discovered because it collided with the Earth and it burned up in the lower atmosphere of the Earth. So in 2019, we discovered it with my student in a government catalog of meteors. We noticed that it moved very fast, and we wrote a paper about it. And we submitted it to the Astrophysical Journal. And guess what? People who worked on rocks all their lives on meteors said, no way, this will not get published. They rejected the paper, and they said, we don't believe the US government because maybe they have much larger uncertainties than the deviation of this object from being bound to the sun. And so I had some connections as the chair of the board on physics and astronomy of the National Academies in the US. And it took 3 years for the US Space Command under the Department of Defense to issue this letter that you see on the left, which basically, this is very unusual, by the way. The scientists are skeptical, they don't want to believe anything, and then the government comes forward and says, we confirm the assessment of my student and myself that this meteor that was discovered on January 8th, 2014, came from outside the solar system at the 99.999% confidence. So after 3 years, now with this letter, the referee was willing to accept our paper for publication in the Astrophysical Journal, but the referee still said, well, this is not particularly significant. This is not too interesting. Well, guess what? This is the first interstellar object we found. And the government also released the fireball from this object. It exploded 18.7 kilometers above the ocean surface. And from that, we calculated that the ram pressure of the air at the point of where the object disintegrated was a few times bigger than the material yield strength of iron. So this object was tougher than iron. Obviously, it's unusual. It was the toughest meteor among all 273 meteors in the catalog, an outlier. So not only it was the first interstellar object, but it was also extremely unusual in material strength. And then a month ago, we found the second one in the same catalog, and it's also an outlier. So the chance of drawing both of them from the distribution of material strength for all other meteors is 1 in 10 to the 4 to 10 to the 6, depending on how you fit. If you fit it with a Gaussian, it's 1 in 10 to the 6. The chance that these interstellar objects are drawn from the same material strength distribution of solar system objects. That means that the source of these interstellar objects is not a planetary system like the solar system. We know that. So we want to figure out what this meteor was made of. It landed 100 miles off the coast of Papua New Guinea. So we are going there. The minute I announced that we want to go there, I wouldn't say the minute, but it took a couple of months. I got $1.5 million from a Zoom meeting with a very wealthy individual that said, no problem, you have the money. So we are going there. And guess what? All these experts, all these bloggers that actually have no expertise were bashing this mission. They were saying, oh, why should we do this? But we are not using money that was allocated to any other scientific mission. We are driven by curiosity, and yet people have a problem with that. And the way I see it is whenever people see a flower growing above the grass level, they tend to step on it for no good reason. Even though it's clear that it's a win-win proposition here. We will learn something new about interstellar objects. What's the problem? Even if it's natural, it will be very interesting to figure out where it came from. So within the next half year, we are going to Papua New Guinea to recover the fragments from this meteor. And we will use a sled with a magnet and collect those fragments and figure out the composition and try to infer whether it's an iron meteorite or maybe it's made of an alloy like stainless steel, which would mean that it's artificial in origin. Coming back to Oumuamua, that was much bigger because we cannot see objects that are 0.5 meter in size from the reflection of sunlight. If they come within the orbit of the Earth around the sun, we need them to be very big, like a football field, and that was Oumuamua, much bigger. There should be 1 million meteors for every Oumuamua-like object, like that. But at any event, Oumuamua came from a very special frame of reference called the local standard of rest, which is the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And only 1 in 500 stars is so much at rest in the local standard of rest as Oumuamua was. And when it approached the sun, it was given a kick by the gravitational field of the sun. And it was tumbling every 8 hours and had a brightness that changed by a factor of 10. So that means that the area projected on the sky that the object showed changed by a factor of 10 as it was tumbling. And the best fit for that, there is a paper on that. I didn't write this paper. Someone else wrote this paper in 2019 saying the best fit at the 90% confidence is a disc-like shape, a pancake. Very unusual. Doesn't sound like a rock to me. But moreover, it exhibited an excess push away from the sun, non-gravitational acceleration. So you would say, okay, well, maybe it's a comet, gas is evaporating from it, and there is the rocket effect that is pushing it. But then on the top right, you see an image from a very deep image from the Spitzer Space Telescope, and it's basically just noise. So not only that we don't see with our eyes a beautiful cometary tail, as usually you do, and the object had to evaporate, at least 10% of the mass of the object had to evaporate in order to produce this push. We didn't see any cometary tail reflecting sunlight, but moreover, the infrared data from Spitzer ruled out any carbon-based molecules in the vicinity of the object. And the repulsive force from the sun declined inversely with distance squared. So we suggested, okay, maybe it's reflection of sunlight that is pushing it. And for that, the object had to be very thin, like a sail. So nature doesn't make such things. And I suggested, okay, well, maybe it's artificial in origin. So our paper was accepted for publication within a few days, but then there was a huge pushback and a huge interest also from the media. But, it's just a matter of getting more evidence. But the mainstream astronomers, of course, said, no, it's natural, exclamation mark. And that was a review paper in Nature Astronomy magazine. But then a few months later, some astronomers said, oh, well, but it has some anomalies. We have to explain them. We cannot just claim it's natural, like this group of people did in Nature Astronomy magazine. So they came up with suggestions. One team said, oh, it's just a dust bunny, a very fluffy cloud of gas, 100 times less dense than air, being pushed by reflecting sunlight. And the problem with that is when it gets close to the sun, it will get heated by hundreds of degrees and will not maintain its integrity. So then there was another suggestion, maybe it's a molecular hydrogen iceberg. And then when hydrogen evaporates, there is a cometary tail of hydrogen which is transparent. The problem with that is that hydrogen evaporates very easily, so it wouldn't survive the journey. So we wrote a paper about that, and the authors of this suggestion said, yes, you're right. So then a third group, a few months later, said, well, maybe it's a nitrogen iceberg chipped off the surface of a Pluto-like planet. And then we wrote a paper saying, well, the problem with that is the mass budget. There is not enough solid nitrogen in the Milky Way galaxy to produce enough chips so that you would see one of them in the Pan-STARRS survey. So all of these suggestions have problems, and all of them talk about something that we've never seen before. The fundamental question is whether Oumuamua was natural or artificial in origin. And it could be just like walking on the beach. Most of the time you see rocks and seashells that are naturally produced, but every now and then you see a plastic bottle. So that may have been Oumuamua, and that indicates a civilization somewhere. In fact, 3 years later, the same telescope in Hawaii, Pan-STARRS, discovered another object which shared the qualities of Oumuamua. It was given the name 2020 SO. It was discovered in September 2020. It was pushed away by reflecting sunlight, and it didn't have any cometary tail. And then it was realized that it's actually a rocket booster launched by NASA in 1966. And it was made of stainless steel. So that's why it was pushed by reflecting sunlight, because it had the thin walls, a large surface area for its mass. And obviously, stainless steel does not produce a cometary tail. So we know it's artificial. The question is, who produced Oumuamua? And the way I see those experts that worked on comets and asteroids all their lives is like a cave dweller used to playing with rocks. If the cave dweller would find a cell phone, he would say, well, it's a rock of a type that I've never seen before. But if he presses a button, he might realize that it can record his voice and then realize it's not a rock. Now, this discussion about Oumuamua inspired a winery in Santa Cruz, actually, to produce this bottle that you see here. And we used it at the conference of the Galileo Project at the banquet. We ordered these, and actually the Bonnie Doon Vineyard, which is very good, actually, arranged the press release about that. This is so there is a new frontier in astronomy now, which is studying interstellar objects, two of which we discovered with my student, the two meteors, and the other two are Oumuamua, and then there was a comet, actually, Borisov, that looked just like a comet. And so the answer to Enrico Fermi's question, where is everybody, is that in order to find your neighbors, you better look up, you better look through the windows, and you better use a telescope. Now, the US government actually delivered a report to Congress, the Director of National Intelligence, talking about objects that cannot be understood. And they don't belong to adversaries. They do not look like human-made technologies. So, there is room for scientists to figure out what they are. And the coming years will be exciting. So the Galileo Project was established a year ago to address the challenge. And I should say the Drake equation is of very little relevance here because we are not searching for a radio signal. Such a search is equivalent to looking for or waiting at home for a phone call. You can wait for a phone call, but in fact, you should check your mailbox because maybe there are letters piling up in your mailbox, and that's a completely different thing. So the Drake equation is about waiting for a phone call, whereas the Galileo Project, or what I was describing before as a search for objects, is going to the mailbox and checking whether there are any letters there. And the senders may be dead by now, okay? But the letters would still be there because they are gravitationally bound to the Milky Way galaxy, those any chemically propelled objects moving at a few tenths of kilometers per second. The escape speed is hundreds of kilometers per second. So the chance of finding them depends on the survey volume and then the number of objects per unit volume. That's very different from the Drake equation. It's the cumulative number that matters here. And if you use the Earth as a fishing net, it depends also on the speed of the objects. And of course, the speed and the number would depend on size and mass. But most importantly, I include here also the ostrich factor. If we don't look for these things, we will not find anything, which is pretty much what was done in astronomy until now. So we will not discover if we don't search. Let me skip. So a picture is worth 1,000 words. That's the usual statement. But in my case, it's worth 66,000 words, the number of words in my book. I would much rather distribute a photo album of Oumuamua than write my book. Just show what it looks like. Does it look like a nitrogen iceberg? Does it look like a hydrogen iceberg? Does it look like a dust bunny? Let's get more evidence rather than say, it's natural, forget about it, let's move on. So what you see on the right side is an image of the asteroid Bennu that was taken by the OSIRIS-REx mission. And what we hope to do with the Galileo Project is design a space mission that will rendezvous with the next Oumuamua. And we have a dating app. It's called the Vera Rubin Observatory. It will start operations in a year or so with a 3.2 billion pixel camera. And I call it a dating app because it would find candidates that look just like Oumuamua every few months probably. And most of the time we would swipe to the left, except for an object that would look so unusual that we might send a spacecraft to rendezvous with it. This kind of a date is very expensive. It's more than $1 billion. So it's a very expensive date. We have to be selective as to who we date. And we can use the Webb telescope as well to look at such an object because it gives us a different angle looking at it. It's 1 million miles or 1.5 million kilometers away from Earth. So it will provide us with a parallax and a very precise determination of the trajectory in 3 dimensions of such an object. So we can figure out if only the force of gravity or something else, there is some propulsion that is moving this object. And perhaps Oumuamua was thin and flat because it's a leaflet carrying a message. And in that case, it would be tragic if we missed a love letter in our mailbox. I should say that the way we behaved so far is not very impressive because we sent, for example, the New Horizons spacecraft with a small box attached to it. And there were 3, it was sent originally towards Pluto. And we put 30 grams of the ashes of the discoverer of Pluto, Clyde Tombaugh, in that box, as if to celebrate his discovery of Pluto. But if an extraterrestrial finds this box, it will be very embarrassing because they will say, what is this primitive ritual of burning the genetic information about a person that the humans wanted to commemorate? That makes no sense. These ashes are no different than the ashes of a cigarette. If you want to commemorate a person, you would rather put an electronic or digital record of the DNA of that person or a stem cell. So my idea is to send a spacecraft moving faster than New Horizons and apologizing for this box because it doesn't show that we are intelligent. And as I mentioned, the government is talking about objects whose nature is not clear. And the Galileo Project will try to, in addition to rendezvousing with objects like Oumuamua, also identify the nature of those unidentified aerial phenomena. And so we, by now, assembled a suite of instruments that take a video of the sky in the infrared, the optical, the radio, and audio. And we are starting to get data from them actually this coming week. And then after we test them, and we will have artificial intelligence algorithms analyzing the data, and then we'll move the system to various locations. And we first put the system on the roof of the Harvard College Observatory, but now it's actually in a different location. And before I finish, I just wanted to mention the analogy with the search for dark matter, because that will be discussed. And that's one of the fundamental questions that we have in cosmology. And, my conservative colleagues often quote Carl Sagan, and as if, they want to demonstrate that taking risks doesn't make sense. They say extraordinary claims require extraordinary evidence. My point is that extraordinary evidence requires extraordinary funding. And the best example is the search for dark matter, because for several decades, it was argued that the lightest supersymmetric particle is the dark matter. For the last 40 years or so, people claim that, and there is a very natural parameter space for that. And then we invested $10 billion in the Large Hadron Collider. Aside from the old news of confirming the Higgs boson, this was the highlight, supposed to be the highlight. We didn't find anything. Okay, it's not a waste of money, $10 billion. It was reasonable to look for it, but my point is there was no extraordinary evidence for that. Obviously, we didn't find it. So if we were to allocate even 1% of the 10 billion in the search for equipment from extraterrestrial civilizations, we might actually uncover something really fundamental that is of great interest to society, to the government, and so forth. And, Fermi's paradox, Enrico Fermi, back in 1950, went to lunch at Los Alamos and asked, where is everybody? And it's possible that most of them are dead, billions of years later. We know that the sun will burn up the surface of Earth within 1 billion years. We just have about 20% left in the life of the Earth for us to be here. Other stars are more than 1 billion years older than the sun, so the civilizations are not around anymore near them. That's most likely. But we can still find the artifacts of dead civilizations, and they would appear as space trash or as functional devices that I call AI astronauts, artificial intelligence astronauts. And of course, we don't have a protocol for how to engage with a visitor. There is no organization that represents Earth. But my hope is that by finding relics of a smarter kid on our block, we would get inspired. Because if you look at human history, it's shaped most of the time by a group of people feeling superior relative to other people. And if we realize that there is some other beings much smarter than all of us, perhaps we would realize that the differences among us are meaningless. And so we would treat each other as equal members of the human species. And the most important message from the universe is that the cosmic play is not about us, because we are not at the center of the stage like humans thought initially. And also we came to this play only at the end. You know, the universe existed for 13.8 billion years, 100 million times more than modern science and technology. So, you know, and in fact, recorded human history is only 10,000 years old. That's a millionth of cosmic history. So how dare we think that the play is about us? You know, if you arrive late into the play and you see that you're not at the center of the stage, it's not about you. And maybe the way for us to find what the play is about is to look for other actors. Thank you. I'll be glad to answer questions.
All right. Thank you for your presentation. So I think we last spoke about a year ago when the Galileo Project was just getting started. And so it's really nice to see what you have planned and what's been developing since that time. I do have a question. You know, we both are in fields where, and I think this is a problem with science in general, where there's a lot of resistance to anomalies. I'm wondering why you think, if you could say more about why you think that is, and also if you think perhaps we're in this era now of private space exploration, and do you think it's possible that we can start to, you know, collaborate with that facet to maybe get a head start or ahead of some of these anomalies and some of these questions that we want to explore?
Right. Okay. So the resistance to anomalies comes from two sources. One is experts get their self-esteem, their reputation, their status, their professional honors and awards out of claiming that they can explain anything that comes along based on past knowledge. That's the meaning of expertise, that everything you learned or you developed allows you to figure out what you see. Okay, so that's the meaning of an expert. So people have established their reputation as such, and therefore if they explained everything in the sky in terms of rocks, they want everything in the sky to be rocks. So if you see an anomaly, that's a problem. You know, there was a colleague of mine that worked for decades on objects in the sky, and when we left a colloquium on Oumuamua, he told me, Oumuamua is so weird, I wish it never existed. So they really don't want it to exist. Okay, and the problem is reality is whatever it is. You know, you can wish that it doesn't exist. You can say the sun moves around the earth, but then it doesn't matter. If you wanted to design a space mission, you have to take into account the motion of the earth around the sun. So if you have a false notion of reality, you will, you know, collide with a brick wall, because reality is whatever it is. You better adapt to it rather than insist that reality is what you think it is. Okay, so it's not like politics or social media where you can gain enough likes so you feel comfortable and you live in your own bubble. Reality, if you want to manage it, you have to adapt to it. There is no choice, and that's why a lot of experts lose a new important knowledge. They never pioneer it because they are entrapped in their prestige and image and so forth. So that's one reason. And they would try to brush it off as much as possible. Okay, so that you find everywhere. The second thing is there is a lot of noise, obviously. So for example, just to give an example, there was a paper from Ukraine a few months ago arguing that they see unidentified objects above Ukraine. Now, my issue with that was, we know that there is a war going on there. There is a lot of noise. There are bullets, there are, artillery shells, there are satellites hovering for intelligence purposes. We don't know all the partners that are looking over Ukraine when the war is going on. So why would you look for unidentified objects when there is so much noise? But at any, and in fact, they wrote a paper about it, and I criticized that paper because they didn't rule out the noise. Okay, so that's the other thing, that you have to be very careful of anomalies that are at the level of the noise. Okay, because otherwise you will be fooled very often, you will be wrong very often, and you will spend your life worrying about things that are not real. Okay, so that's the most important. Now, how do you resolve that? Very easily. You just collect evidence to a level that makes it indisputable. Okay, so the way to avoid chasing noise is to just improve the signal. Okay, and so I would say, first of all, you have to maintain your childhood curiosity. And that is difficult for adults because they want to maintain their image. And I have no issue with that because I don't have any social media presence. And I pretty much maintained my childhood curiosity. Anyone that knows me would say I'm very similar to the way I was as a kid, So I somehow preserved that, because I avoided friction with other people. I tell young people that, if you go to the beach, you find these seashells, and when they're young, they have their own colors and shapes. But over time, because of the ocean waves, they rub against each other and break up into indistinguishable pieces that lose their unique colors. And I just tell young people, don't spend all your time on social media because you are rubbing against other people, you're becoming indistinguishable and you lose your unique colors. So maintaining a distance from the crowd is really important. Maintaining a distance from yourself also in terms of your ego. Not insisting on the paradigm, but being open-minded. That's really important. At the same time, you don't want to cry wolves when there is no wolf. Okay, so you want to rely on evidence that is indisputable. So in the case of Oumuamua, the evidence was there. It's just the interpretation that people were arguing about. And I said, look, this is unusual. Okay, so I insisted on that because the data was very high significance. In the case of the Ukrainian data on unidentified object, I said it's not sufficiently significant relative to the noise. So you have to sort of protect yourself from that.
I love that advice. Work on boosting the signal. Get a better signal. That's great advice for, I think, a lot of fields, including the one that I'm working in. We have time to just take one question. And so I'm going to show this one on stage. This says, Dear Professor Loeb, did you deal with 5D relativity and would take a look on it as a candidate for a UAP drive?
Okay, so first I should say, despite the fact that it's very popular in the context of string theory and theoretical particle physics to talk about extra dimensions, we have no idea whether string theory has any relevance to reality. Okay, because for almost half a century, it was just mathematics. There were many options offered in the mathematics, not even a unique option. And extra dimensions, all the experimental tests did not reveal any evidence for extra dimensions. So why are we talking about another dimension if we don't have evidence? It's really strange because on the one hand, mainstream scientists say extraordinary claims require extraordinary evidence. But then when a group of hundreds of people says, extra dimensions are interesting because mathematically speaking, it resolves some issues for me, then everyone says, yeah, extra dimensions, let's talk about it for 5 decades. And let's make it mainstream and let's give each other awards about it. But there is no evidence for that. So isn't that extraordinary claim? And why is everyone working on it? So, it's really strange. The mainstream can on the one hand say you need evidence, but then work for 5 decades on something that has no evidence whatsoever. It's just a matter of popularity. So the fifth dimension, we don't know if it exists. We can talk about it, but it may be just fantasy. It may be interesting for mathematics. Now, For driving, I just wrote an essay a few days ago about gravitational propulsion, and it's on Medium. I advise you to have a look at that. One thing we know is the universe is accelerating its expansion. And that's a result of the vacuum having some energy density. That's negative gravity, repulsive gravity. And you can imagine that, it's engineered. In principle, you can imagine a vehicle that uses the vacuum for propulsion. It's possible in principle. We know it exists. It's not a fifth dimension. It's something in reality. And the question is how to excavate the energy of the vacuum. We don't know because we have only a century of science. Once we understand the nature of the vacuum, maybe we will use it for propulsion. So I'm saying, let's not think about hypothetical scenarios of extra dimensions. Let's think about what we know exists that we don't understand, which is dark energy and dark matter. And we will hear more about it now. Why are we driven into hypothetical scenarios of extra dimensions? Just because they are popular and some mathematically inclined people claim, that is fancy math, that we can demonstrate that we are smart. I say, that's not relevant. You can demonstrate that you can do intellectual gymnastics as much as you want. We just have to focus on reality. And by the way, it's really strange because in politics, you find all these narratives that have no root in evidence. And the academia says, politicians, they don't pay attention to science. They don't pay attention to evidence. But look at the scientific community. Look at the academia. In academia, you find exactly the same trend of all kinds of speculative ideas, while there are a lot of things about reality that we don't understand, like dark matter, dark energy, or even consciousness. If you go beyond physics, and artificial intelligence offers a new frontier. So my point is there are so many intellectual challenges. Why are we focusing on hypothetical scenarios for 5 decades, investing lots of funds? Most of the talented people go there. It's just wrong.
I like your phrase, extraordinary evidence requires extraordinary funding. I'm going to borrow that one. So that is our time for today. And we are going to have more presentations today, and I think at least 2 of them on dark energy and dark matter. And so everybody, please stick around. We will be back in a few minutes with our next speaker. Thank you very much, Professor Loeb. And hopefully we can check in again in another year.
Thank you, Annalisa. Hopefully we'll know the answers to some of these questions.
Indeed.